right. This is actually review day 5. For some reason, I had a little moment and put 4, so I'm sorry if that confuses you. All right, so this is going to be pretty quick. You don't have calculators if you haven't noticed. We're using them for our EOC today, so can't have those, so we're just going to do it by hand. Transformations, we have a dilation. It changes in size, and we're going to multiply, and I do want you to box the word multiply. Translation is a slide, and we're going to add or subtract. So I do want you to box add or subtract. Reflection is a flip over the y-axis, and a flip over x is going to change my coordinates from x, negative y, and it's going to change my flip over the y-axis. Just think of it this way. Y is going to stay the same because that's what you flipped it over. Okay? Rotation's the hardest one. And so it's the one that turns. And so if it's a clockwise turn, you're going to slide and flip, bring down. Slide and flip, bring down. Slide and flip, and bring down. And counterclockwise. This shows up every year on STAAR tests. Every single year. So study this. So here's actually an old STAAR question. Coordinate grid shows a parallelogram. Parallelogram, PQRS, is rotated 90 degrees clockwise. About the origin, to create a parallelogram, P prime, Q prime, R prime, S prime. Which rule describes the transformation? So if you've memorized your rules, that's awesome, right? I mean, we can just write this out and we're good. But if not, take a piece of patty paper, do the rotation, and then pick a coordinate. So pick your S and write it. Pick your S prime and write it and say, what happened? What happened to my X? What happened to my Y? So let's go ahead and do that. I'm going to grab a piece of patty paper, which you are allowed to have on STAAR test, and we're going to look at how to do that. So I'm going to start by looking at this S. That S is a -3, 2. So it's my X and my Y for my S. Alright, so I'm going to come to my patty paper. I'm going to trace my axis. This works better actually with a pencil, but I know it shows it better. That's my S. So that's what I really care about. So I'm going to rotate clockwise. Clockwise is going this way like a clock. And 90 degrees is going from one axis to the next axis. So there's my new S coordinate. So let's look at what it is. It's 2. And then 1, 2, 3. Okay. 2, 3. So let's look. So my X went over here. So now I have an X, and it's its opposite. And my Y is now here, and it stayed the same. So my change was Y negative X. I can also see 90 degrees clockwise was Y negative X. All right, congruence and orientation. Preserving means to keep. Congruence means it's equal. Orientation means it's not the same direction. Congruence is preserved. It's kept with translation, rotation, reflection. But not dilation because it changes its size. Remember, it grows, so it's not keeping its size. Orientation is kept by translation, rotation, dilation. But not a reflection because I flipped it over to the other side. All right? Scatter plot predictions. And I told you this video is pretty quick. So sorry. If you have questions, I'll be able to answer them when I come back. Plot the points that are given to you and choose the point that falls in line with the data best fit. You can also draw the line of best fit. So based on the trend in the scatter plot, approximately how many people will be in attendance at a movie theater with 8 screens? So we're going to go to 8 screens and I'll plot a 90. There's my 90. So that's my F. Then I'm going to go to 8 screens and I'm going to plot a 105, which is about right there. And then I'm going to plot an 85, which is about right there. And then I'm going to plot a 140, which is up here. So if I see my line is kind of going about right here, I can see that that 140 is too high and this 85 is definitely too low. And honestly, this 90 is too low also. 105 fit in best with the data. This is one of those concepts I feel like is a pretty easy concept, but you got to read the question carefully and take your time on it. So I want you to practice this one. So I want you to go ahead and try this one. So based on scatter plot was the best prediction of the average number of hours a person spends at work each week if that person spends an average of 10 hours. Okay? On the recreational every week. All right? So I want you to go ahead and figure this one out, and I want you to work on it by yourself. Read the question carefully. It's saying 10 recreational, so this one's a little different from the last one. All right, I'm going to give you about 1 more minute, and then we're going to go over it, all right? If you're done, you're just sitting patiently waiting for the other people, giving them time to think about it. All right, it hasn't been quite a minute, but I feel like we should all be done with this. So 10 recreational. This says recreational, so I'm going to be looking at 10 here. So we're going to go to 33. That'd be about right there. I'm going to go to 10. I'm going to go to 85, which is about there. Then I'm going to go to 50, which is about there. And then I'm going to go to 65, which is about there. All right, so here's my line of best fits, roughly right here. I also like to, I'll do this in pencil, this next part, but I also sometimes like to just look kind of at the window of it. And there's 2 dots that are kind of close, but one of them definitely falls better in line, and it's at 65. All right? Scatter plot predictions. All right, let's go to solving for a variable. So we're going to distribute if we need to, combine like terms, move all variables to one side, move all numbers to one side, use our inverse to get the variable by itself without a coefficient. So we have 3x plus 2 equals negative 2 parentheses x plus 4. So I'm going to distribute. Remember, I have to give it to everything. So that negative 2 has to go to the x. Negative 2x. Bring down my plus. Negative 2 times 4 is negative 8. Combine my like terms. I don't have anything to really combine, but now I need to move my variables. So I moved my negative 2 because I kind of wanted to get rid of that negative 2. I like to keep positives, so I added 2x. It's opposite of negative 2 to both sides. Then I subtract 2 from both sides. This left me with 5x left on the left, negative 10 on this side. Then I divided both sides by 5. I can then go in the calculator and type 3 times negative 2, because that's what I think x is, plus 2 equals negative 2 parentheses negative 2 plus 4. And it'll tell me true or false. If I did it wrong, it's going to say false. So if you have 4 answer choices, you can plug each of them in and see which one gives you true. All right, so I want you to try to do practice number 1 by yourself. And I'm going to give you a couple of minutes to work on that. And remember to follow those steps, and every single one of you are trying it. Ms. Lamb is going to call you out if she looks up and you are not attempting this. Remember to use your inverse operations. Remember to get all variables to one side. We don't want to split our coefficient. That's that number in front of a variable. We don't want to split that until we've got them all onto one side yet. I'm going to give you about 20 to 30 more seconds, and then we're going to go over it together. If you are finished, you're just waiting patiently. If you still haven't even begun to try it, you need to go ahead and try it. those parentheses, so I'm going to distribute. So I have 2x, bring down my plus, 2 times 3, which is 6. Now I want to bring everything to one side. Now you can bring your 3 over, but it's going to do negatives. So I'm going to bring my 2x, so I'm going to subtract it. Now if you brought your 3 over, you might have still gotten the right answer because it still works. So I have 1x. Just put it as x, because remember 1x and x are the same. The opposite of adding 1 is to subtract 1. And so we get x equals 5. And I can plug that in. 5 plus 3 is 8, times 2 is 16. 3 times 5 is 15, plus 1 is 16. It worked out. All right, last thing is equations and inequalities. This is really hard for me to put into a note form for you. So I've tried my best here because being able to write equations from a word problem is just one of those things you have to practice doing. So if something is happening multiple times or there are multiple of that item, it gets multiplied by our variable. It can be worded as each. If something is happening one time or an initial amount, so something we start with, it will be added or subtracted. So let's look. And this is for equations and inequalities. Veronica is ordering trophies for her school. Company P, so I have Company P on this side, charges $3.50 for each trophy. That tells me I'm going to be doing $3.50 times every trophy. And a one-time engraving fee of $25. That's my one-time initial thing. It's only happening once. Okay? Company R charges $7.50 for each trophy. Think of that. Our amount's going to change depending on how many trophies we have. That's why my trophies is the variable, because it changes. And a one-time engraving of 17, so I'm going to add 17. Which inequality can be used to find x, the minimum number of trophies that can be ordered so that the total charge of P is less than. So I want P to be the smaller, the total of charge. All right, so let's see which one matches. Well, this one doesn't have, this one's multiplying that one-time fee by my trophies. This one also is doing the same thing. So these two both have my x in the right spot, but we need to check our symbols here. And so H is correct. All right, this is what we're doing for Olympics. Remember that you also have extra credit that is due today. I will accept it all the way to midnight, so if you want to go home and work on it tonight, that's great, but I will not accept it tomorrow. All right, I will see you all tomorrow or later today.